Hey there, tech enthusiasts! Today, we're diving into the exciting world of DHCP, a protocol that automatically assigns IP addresses to devices on a network. DHCP is incredibly useful and makes life much easier for network administrators. Imagine a situation where each device needs a unique IP address to connect to the internet. It's quite a hassle for network administrators to keep track of all these addresses, especially when devices are being added or removed from the network regularly. This is where DHCP comes in to save the day. When you connect a new device to your network, it sends something called a DHCP request to your router. The router then responds with a DHCP offer, providing the device with an IP address, subnet mask, default gateway, and other necessary information. Once the device acknowledges the offer by sending a DHCP acknowledgement back to the router, it's all set up and ready to go. What's more impressive is that this process can support thousands of devices simultaneously. The protocol itself is quite efficient in allocating IP addresses dynamically across large networks, while also keeping track of which addresses have been assigned and which are still available for use. This way, no two devices will ever have the same IP address on your network. When a device disconnects from the network, it sends something called a DHCP release message back to the router, which then marks that specific address as available for future use. DHCP Basics. DHCP simplifies network administration by dynamically assigning IP addresses to devices, eliminating the need for manual configuration. When a device connects to a network, it sends a DHCP request, and a DHCP server responds with an available IP address lease. DHCP Components. DHCP Server. This is a network device or software that manages IP address allocation. DHCP Client. Any device requesting an IP address from the DHCP server, such as computers, smartphones, or IoT devices. DHCP Lease. The duration for which an IP address is assigned to a device. After the lease expires, the device must renew its IP address lease. DHCP Process. DHCP Discovery. The client broadcasts a DHCP Discover message to locate available DHCP servers on the network. DHCP Offer. DHCP servers respond with a DHCP offer message containing an available IP address lease. DHCP Request. The client selects an offer and sends a DHCP request message to request the offered IP address. DHCP Acknowledgement. The DHCP server sends a DHCP acknowledgement message, confirming the IP address lease to the client. DHCP Relay Agent. In large networks with multiple subnets, DHCP relay agents forward DHCP messages between clients and servers, ensuring DHCP requests reach the appropriate DHCP server, even across different network segments. DHCP Options. DHCP options provide additional configuration parameters to DHCP clients, such as DNS server addresses, gateway addresses, subnet masks, and more. These options enhance network functionality and flexibility. DHCP Reservation. DHCP Reservation allows administrators to assign a specific IP address to a client based on its MAC address. This ensures that certain devices always receive the same IP address, facilitating easier management of network resources. DHCP Failover. DHCP Failover provides redundancy and high availability by allowing the DHCP servers to share IP address lease information. In case of one server failure, the other server can seamlessly take over DHCP operations, ensuring uninterrupted network connectivity. So there you have it. DHCP is an essential protocol that makes our digital lives much easier and more efficient. I hope you found this tutorial helpful and insightful. Thanks for tuning in. Don't forget to hit that like button and subscribe for more tech tips and tricks. Until next time, stay tech savvy.